Mamma mia, ma potremmo dire che... Cosa mi racconti? Spero. Ciao. Hello, guys. Can you hear me?
Yes.
How are you guys doing?
Good. Good.
Yeah. But I couldn't make it to the campus, so I decided to have it remotely. Let me start by taking you to your classroom. I think I opened it somewhere else. Let me see. I have it here. Okay. I'm gonna share it with you now. This is your classroom. This is what we have this week. Um, we continue from chapter 6, where we stopped last time. And then assignment, we have 3. Excel assignment 4, classwork 4, 6, and homework 6. And you can see the due date on the screen. Now, chapter 6 is on probability distributions. We started it last week. And of course, you know that you can access all this from the models. If you click on the models and scroll down to the models, you can see everything right here. The Excel assignment 4, I believe I put it somewhere. Oh, right here. This is right here. The Excel assignment 4. You can see homework 6 and classwork 6. After the class, I will put the classwork 6 for you and make it available after the class, as soon as we finish. And now, let us begin. So last time I introduced probability distribution, and we did some examples. Now we continue to what we call expectation or expected value. Expectation or expected value simply means, well, give me 1 minute, just 1 minute. Make sure everything is good. Yeah, it simply means the probability distribution. It means the theoretical average of that variable. So, in other words, the expected value of a discrete random variable of a probability distribution is the theoretical average of the variable. So, which means that we use this formula for it, to finding the expected value of a discrete random variable of a probability distribution. So it is theoretical average. So we use mean to represent it. That means sum of x times the probability of x. Let's apply it to this example. It says a lottery at Mount Carmel's Catholic Church annual bazaar offers 1,000 prize, one 1,000 prize, one $500 prize, and $500 prizes. So 1,000 tickets are sold at $3 each. Find the expectation if a person buys 1 ticket and if the winning ticket is returned to the pool after each draw. Okay? After each draw. So first thing is to find the probability of winning. To win is you say that the 1,000 ticket are sold. So it's 1 out of 1,000. 1 divided by 1,000, which we can find the result from answer from our calculator as um I don't even know who this okay. Okay, good. 1 over 1,000, 1 divided by 1,000, 0.001. Okay, 0.001. Now, probability of losing, not winning. You know, the complement of that will be 1 minus this. But remember, we have how many prizes? One, two. We have one $1,000 prize, one $500 prize, and 500 prizes. So that the probability of loss will be 1 minus the complement of that, but for each of them. Remember, each prize, you bought one ticket, the person bought one ticket, so you have 1 out of 1,000 of winning each prize. So now we have how many prizes? 7 prizes. So 1 minus 0.001 for the first prize, 0.001 for the second prize, plus 0.1 for the third prize, plus 0.001. How many prizes have 7 prizes for the fourth prize? 0.001. Okay, 1, 2, 3, 4, for the fifth prize, then sixth prize is 0.001, and the seventh prize is the probability be 0.001. Close parenthesis. So you have 1, 2, 3, 4, 5, 6, 7. So that the probability of a loss becomes, you put this in a calculator. Okay. We have, okay, 1 minus 0.001 plus 0.001 plus 0.001 plus 0.001 plus 0.001. So 1, 2, 3, 4, 5. 2 more. Plus 0.001 plus 0.001. 0.993. 0.993. So we can put it right there as 0.993. Okay. 0.993. 0.993. Okay. Let me make sure I copied it the right way. Yep, 0.993. Okay. Now go back to that place. So we can now say, okay, have one. Okay. Now we have the probability of winning and the probability of loss. So let's say now the win, let's say for $1,000. Okay, $1,000. The channel win $1,000. The other one is $500. Okay. Then the third one is we have the $500 prizes. Give me 1 minute. Give me 1 minute, please. This is an important call. Yeah, baby, I'm in my class. Yes. Okay, I have begun on the class. All right. Sorry about that. You just said important call. So somebody just came in. Let me check the person. Yeah, $500 price. Now we have $500 prices, so I'm gonna write them here. 100, 100, 100, 100, 100. That's this represents the $500 prices. Then, of course, you lose. Note that if you pay $3 for the ticket, if you lose, nobody will give you the money back. If you win, nobody will give you back the money. So because of that, instead of writing $100, $1,000 here, I'm gonna write 997, because even though they will give you a check for $1,000, your net gain will be 997, because nobody will give you the $300 back. So I'm gonna have here as 997, which means that this 500 will be changed to 497 for the same reason. And all these $100 is changed to 97 for the same reason, because nobody will give you the $3 back in as much as they give you the check for the amount you win. Your net win will be that minus the $3. Okay? And this 97. Now, of course, this is assuming that if you win any of them. Now, most time you lose. So for that, you're gonna write -3 for the loss. You lose. So for each of these, now let's say for the win, the probability of winning is 0.01. So you have 0.01 here for each of them. Oh, actually 0.001. Okay, 0.001, 0.001, 0.001, 0.001, 0.001, 0.001. Now, if you lose, the probability of losing is 0.993. See? Now, you can now find it. Remember, the formula is x times px. All these things wins are the x. And this is the px. You can see the s times px. So 997 times 0.001 will give us 0.997. 497 times this times 0.001 will give us 0.497. Now, each of these multiplied the 0.001 will give us 0.297 for all the 97s. Okay? 0.097, 0.097, 0.097. Now, for this one, -3 times -3 times 0.993. Let's calculate it. We share the calculator. We have -3 times 0.993 is -2. Right? Is that negative 2.979. So I'm gonna go there and put it. Negative 2.979. So let us add all this in the calculator, see our expected value. Okay, so I'm gonna write them down. 7.997. The other one is 0.497. Then the rest are 0.097. Yeah. Then to the last one. So let's go and put them in the calculator. So we got 0.997 plus 0.497 0.097 plus 0. There are 5 of them, 0.97 plus 0.097 plus 0.097 plus. Now, the last one there, you can see that the last number there in the table is the negative 2.979. So plus that, I'm going to put it in parentheses, negative 2.979, which is negative 1. So our answer for that total of that table is negative in dollar sign 1.000. So that's our net gain. That's the expected value is negative $1, which is a loss. So if you check most people that do gambling, scratch off, a million. I mean, sometimes they win. Of course, they win a few dollars. Except unless you win the jackpot. If you don't win the jackpot most of the time, you check all your wins and all your losses, you see that you are losing. So the expected value for this situation is a loss, which is $1. Any question on this? Any question? No question. Good. Excellent. Now let us apply. You have a question?
Yeah.
Okay, go ahead.
How did you get negative 1,000? Do you add those at the end, or
You mean how do I get what again?
how do you get negative 1.000?
You add all this, yes.
Oh, yeah, I do. Okay.
Yeah.
Thank you.
You're welcome. Now let's apply this to business. Now, in case of business, business is more predictable because business is not gambling. I mean, it's a risk, but not gambling. So if your answer is positive, then it could be a good business. Look at this question. It says a Sky Resort located in Cleveland loses $70,000 per season when it does not snow very much, and makes $250,000 profit when it does snow a lot. The probability that it will snow at least 75 inches, that is a good season, in Cleveland is 40%. Find the expected profit. Okay, profit is, he said that if it snows a lot, you make a profit of 250,000. Okay. So if it snows a lot, the Sky Resort makes a profit of 250,000. So I'm gonna write it here, 250,000. And the probability is 40%, which is 0.4. Now, if it doesn't snow a lot, they loses 70,000. That means negative 70,000. And the probability of that, now, if it is 40% chance that it will snow a lot, the opposite is 60% that it will not. So we're gonna be 0.6 here. Now we can now get their x times x, which is to multiply each of them with their corresponding probability. Okay? So 250,000 times 0.4 250,000 times 0.4 is 100,000. So I'm going to go over there and put it in. Okay. 100,000. Now, negative 70,000 times 0.6. That's right. Negative 70,000 times 0.6. Negative 42,000. Negative 42,000. So that our total, which will be our expected value, is to add these two. So we have what we're gonna do is the 100,000 plus negative 42,000, 58,000, which is positive, which is a positive. Positive means that it's a good business, 58,000. So our expected value, which is sum of S times PS, is $58,000. That means it's making a profit, a good business. It's not a loss like the gambling. Any question on this one? Okay, good. Excellent. Now, at this point, I can now introduce you to binomial distribution, a type of discrete probability distribution. So binomial distribution, let's start with the binomial experiment. Many types of probability problems have only two outcomes, or outcomes that we can reduce to two. For example, when a coin is tossed, outcome is two, head lands or tail lands. In a basketball game, no matter how much they scored, no matter how much each team scored, the outcome is two. Either the team wins or they don't win. Yeah. See, two outcomes, or outcome that can be reduced to. When the baby is born, it will be either a male or a female. Blood pressure, no matter what the reading says, it is either normal or abnormal. Again, two outcomes. So this kind of scenarios are called binomial experiments, examples of binomial experiments. Now, a binomial experiment is a probability experiment that satisfies the following requirements. One, each trial must have only two outcomes, or outcomes that can be reduced to two. There must be a fixed number of trials. So now the outcome of each trial must be independent of each other. They have to be independent. Okay. Then the probability of success must remain the same for each trial. Okay. Now for the dice again, for example, we say that the probability of success for the dice have 6 sides, so it's gonna be 1 out of 6. For a coin, it is 1 out of 2. See? So you say that here that the probability of success must remain constant. For a dice is the probability of a 1 showing up is 1 over 6. Also, the probability of 3 showing up is 1 out of 6. So it remains constant. Okay, for each trial. Now, this leads us to binomial distribution. Now, a binomial distribution simply means a binomial experiment, the outcomes that of a binomial experiment and the corresponding probability of each of these outcomes. So, in a binomial experiment, the outcomes I usually consider as either failures or success. Now, here are the notations. Small p for the probability of success. Small q for the probability of failure, which of course for Q we usually use 1 minus P Q. N is number of trials, and then S is number of success in N trials. So for that we use this formula. P of X equals N combination X times P to the power X times Q to the power N minus X for X starting from 0 to N. Now let us apply this to this equation. I'm going to copy the formula so that you can, can apply it there. So whenever you're solving that quick with the okay, I think it's here already. Whenever you're solving a binomial probability equation, use that formula. I will also show you how you can do it in Excel, and that one is even faster. Anyway, let's try this. It says find the probability that in 5 tosses of a fair dice, a 3 appears A at no time, B once, C twice, D 3 times, E 4 times. Yeah, let's do it. The first thing is to find your NPQ. How many times was it tossed? It was tossed 5 times. So your N is 5. Now for the dice, P, which is the probability of success, is 1/6. 1 out of 6 chances. So 1 out of 6 chances would be, you got 1 divided by 6. 0.167 rounded. 0.167. 0.167. Now for Q, remember Q is always 1 minus P. 1 minus P. So you're gonna be 1 minus 0.167. Okay, I'll write this down so you can go and get one day calculator. So 1 minus 0.167. Going to our calculator. 1 minus 0.167. 0.833. So I'm going to go over there and put it right there. .833. Now, with that, we cannot answer the question. Question A says, find the probability that in 5 tosses, of a fair dice, a 3 appears at no time. At no time means 0. So in that case, our x is 0. So we cannot plug it into this equation. Anywhere you see x, you put 0. Anywhere you see n, you put 5. Anywhere you see x, you put 0.167. Sorry, s is 0, not 0.167, 0. But p is 0.167. Anywhere you see q, you put 0.833. So let's add it, put right here. The probability of 0, okay, that appear at no time. I want to make this to be 18 equals, say, n combination x. That means n is 5. 5 combination x. X is 0 times, I'll make these adjustments and make this one as well. Okay, times, okay, I'm gonna make this bigger. Okay, times p to the power x, and our p is 0.167. 0.167 raised to the power x, and our x is 0, times, let me adjustment here. Okay, times, I say q, and our q is 0.833. So raised to the power n minus x, and n is 5 minus x, and x is 0. So I'm going to make the adjustment. Expunge. Okay. So I'm going to adjust this. Raised to the power 5 minus 0. So you can put this in the calculator. I'm going to write it down, then we can go and put it on the calculator. Okay, P0 equals 5,0 times 0.167 raised to the power 0 times 0.833 raised to the power 5 minus 0. 5 minus 0 is 5 anyway, so 5 minus 0. Let's go and put this in the calculator. Last week I showed you how to get combination. So I'm gonna do clearly say 5 combination. You got 5 combination 0. I'm gonna get that from here function 5 combination 0 combination NCR 5 comma 0. Okay, times point 0.167 raised to the power 0 0.167 167 raised to the power 0 times 0.833 raised to the power. Since 5 minus 0 is 0, so sorry, 5 minus 0 is 5, not 0. 5. You mean 0.401, round there, 0.401. Put it here. 0.401. So I'm just gonna go ahead and put it in. 0.401. And as you know that this is said that the P and Q will remain constant for all of them. So answer the first question. So for other ones, you just keep the formula. This numbers here, just change the X. S is anything that will be changed, keep on changing. And here, it said appeared ones. In this case, S is 1. So I'm gonna copy this. Okay. So I'm gonna use it for the next one. So again, N is still 5. And the P is still you are 0.167. And Q is still your 0.833 here. The only that change is X. We see that A3 appear 1, so our X is 1. So the required probability becomes everything the same, except that you change X to 1. 5 combination 1 this time. Excuse me. 1. I'm going to just adjust that so. Times 0.167 raised to the power 1. Times 0.8 raised to the power 5 minus 1. So let's see what the answer will be. You can just go to the calculator and change it, make these changes. Get the results. Okay. So chain 5 combination 1 times 167 raised to the power 1. So 5 minus 1 will give us 4. You know that. 0.402. 0.402. 0.402. Any question on this? Any query? So no question. So I can try number 3 then. Part C, part C. Part C says a 3 appeared twice. So our S is 2 times. So everything stayed the same, except that our X will be changed. So I copy this from here. And press this so we can run. So N is still 5. P is still 0.167. Q is still 0.083. And the X this time around is 2. So we have the probability of 2. Excuse me, sorry, my mistake. The P of 2 Like I say, everything stays the same except the x that change, which is 2. P of 2 will be the probability of 2 is 5 combination 2 times 0.167 raised to the power 2 times 0.8338 raised to the power 5 minus 2. Excuse me. Let me write this down to see what it will give us in the calculator. 5 combination 2 times 0.167 raised to the power 2. That's 0.833 raised to the power 5 minus 2. Let's go and put it in. So I take it back here. We'll just change this to 2, that's all. Okay. 2. 5 minus 2 is 3. 0.161. Okay. It's 5 minus 2. 0.161 rounded. Okay. 0.161. Okay, that's how we do it. So follow that method. You can finish, you can try 3 times and 4 times by yourself. Any question from this floor? Any question on this? Okay. Now I can show you how you can do this using Excel. And then we can try one more example here. Okay. Yeah, we can try 2 more examples. Okay. It says, suppose we want to do this with Excel. We have our numbers. Okay. N is 5. We write them down so we can we can now calculate them. N is 5. P is 1/6. Q is 1 minus P. 1 minus P. And then our X we don't know. So we can just use it to calculate. So let's take it to Excel. And then we can do it in Excel. So I can say P N equal. Make this in a little bit bigger. Okay, make sure I have it. P equal Q equal. So I can come down and write my X. X. I know that for a dice, it has to go from 1 to 6. Actually, the N for binomial, the probability goes from 0 to the last N. So how that's 0, 1, 2, 3, 4. Okay, 4, 5, 6. That PX has the probability of X. PX. Okay. So our N, if you remember that our N is 5, our P is 1/6, and then go from there. So we have taking back to the Excel. So N is 5, P is 1/6. That means equal 1 divided by 6 with this. And Q is equal 1 minus that. 1 minus this. So I can make both of them 3 decimal places. Okay, good. Now, Let us find px. Remember the formula. Okay. Remember the formula. The formula is, let me see if I can insert it here. I'm not sure. Let me try. Equation. Got the formula. P of x. P of x equal. I'll make it bigger. Equals we got I put this. Okay. N combination x. Oh, x. Okay. Times p to the power x. P to the power x raised to the power x times q. This q, I put this q raised to the power, excuse me, raised to the power n minus x. So make it bold. Okay, and make it richer. Let's see if you can embody it. That's the formula I use. Letting this. I'll make it right here. See? The formula right there. Yeah? So let's calculate it, but we're gonna use a set formula. It is called let me put it right here so you can see it. This a set formula we can use is this. It called equals binom dot dist. So this is the Excel formula we're going to be using. Okay. Now let us do it. Let's use it here for this. We have equal binom dot. You see it pops out right here. Double click the number, which is 5. Okay. 5, comma. Trial. Okay, sorry. One is numbers. It's right here. 0 here 0. It's good mistake. I'll move this. But it's 0 right here. Comma. Now, number of trials is 5, 5. See, n is 5. 5. Come on. Probability of success is 0.167. 0.167. Come on. Then we are not doing cumulative. We are doing probability mass function because we're not going to add in our answer to the previous one. So we're going to use false here. False. Press the enter key to give you the answer. You can see that this answer, 0.401, is the same answer we got from the first one we did, 0.401. If you round it up, let me round it up so you can see what I mean by that. If you round this up to 4 decimal places, to 3 them, see, same answer. So I can just copy this down and calculate the rest of them. See? So 5 trials. The last one it says is 0 because you say 5 trials, we stop at 5. Okay? That's why it gives us this. Now, and if you look at the second answer, you can see right there, second answer right there, 402 we got, which is 402. I can see from here as well. That's 402. And if you follow the 161, we got the third one. You got to see 161. If you go there, to the third one, we got for 2. So we got 161. So you can see I've shown you how to do it with formula and how to do it with Excel. Any question, guys? Any question before we continue? Any query?
This form that you have, are we supposed? Well, am I supposed to be copying this or following along?
What form?
The one you're working on right now.
Or this document here?
Yeah,
If you want, I can upload it for you. Let me see if I can save it for you in the desktop so I can upload it for you guys after the class.
because this is considered the classwork, right?
Nope. Classwork is a question I'll give you.
Oh, okay, cool.
Mm. This one is like if you want to use your review, want to study with, you can study with it. So I've saved it on desktop so I can upload it for you guys. Now, since there's no other question, let's do another one. It says it is claimed that a particular flu shot is effective 70% of the time in 70% of the cases. If a group of 15 adults receive the flu shot, find the probability that exactly 10 will benefit from the flu shot. So we said, make sure I see this. First of all, I'll put this one. Say it's clear that a particular flu shot is effective 70% of the time. Okay? If a group of 15 adults receive the flu shot, find the probability that exactly 10 will benefit. So in the 15 adults, we are given the flu shot. So N is 15. And we're looking for the probability that exactly 10. So our X is 10. But our P, you see, the first sentence says that it is claimed that a particular flu shot is effective 70% of the time. So our P is 70%, which is 0.7. And our Q is always 1 minus P. That means 1 minus 0.7. That will give us 0.3. So we can now plug this into this formula to get our answer. Let me see if I still have it. Yep, I got it here. So change this to P. We are looking for the probability of 10. So change this to 10. And our N is 15. Just change this to 15. Oh, excuse me. Make it to 15. 15 combination 10 times our P is, this case is 0.7. Raised to power X. Our S is 10. And our Q is 0.3. Raised to power N minus X, which is 15. Okay. Let's see. 15. I'm gonna make it like this. 15 minus 10. Let's see what answer it will give us. So I'm gonna write this down. Probability of 10 was a 15. I'm gonna make this because I'm gonna adjust this side. 15 combination X 10. So 15 combination 10 times 0.7 raised to the power 10 times 0.3 raised to the power 15 minus 10. Let's go and put this in the calculator. Uh, 15 combination 10 It's gonna be NCR 15, comma 10. Okay, back to main times 0.7, 0.7 raised to the power 10 times 0.3 raised to the power 50 minus 10. Excuse me. 15 minus 10. 15 minus 10 is 5. 15 minus 10 is 5. So 0.206 rounded, 0.206. Answer is 0.20. Let me write it down. 0.206. 0.206. Okay. So that's how we do it. Like I say, I've shown you how to do it with the calculator and how to do it with Excel. Now, this is when they ask you in this form, you use the formula. Now, but sometimes you may be asked to answer this question, but to answer many within the same question. Like here, it says a survey found that 45% of teenage consumers, 1 minute, put the name of this person. Okay, of teenage consumers receive their spending money from part-time jobs. If 6 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs. Use the Binomial probability table. No, we're using Excel. Excel is faster. Okay. In this case, you calculate the probability that if you say at least 3 of them out of 6 teenagers, so we are going to calculate the probability of 3, 4, 5, and 6. So 3 and above. So that means you are going to calculate the probability that 3 of them have part-time job. Then you calculate the probability that 4 of them have part-time job. Then you also calculate the probability that 5 of them have part-time jobs. And the probability that 6 of them have it. The probability of that. So that will take you a long time. That's why it's you can either use table or you can use Excel. Excel will be good for us. So let us go and put in NPQ on that. So let me write the NPQ right now. NP. If you're using Excel, using Excel table, you don't need Q actually, just need NPX. N is 6 teenagers. P is 45%. And X is at least 3. Now let me write it down anyway. There are 6 teenagers. P is 45%, which is 0.45. And then X is at least 3 of them. I mean 3 or more. That means X is 3, 4, 5, and 6. And you're required to calculate the probability of all this. Then add them together to get the answer. So that the probability of at least 6, at least 3, I mean to say, 3 becomes equals to the P of 3 plus P of 4 at the probability of 4 plus probability of 5 plus probability of 6. Okay? And that's what you're going to calculate, and that's to give you the answer. So to do that, we go to, let's put this in Excel, make it faster for us. Write this down, X, just. So with Excel, if we calculate the probability of one of them, then we can just copy it down, to get the rest of them. That is 3, 4, 5, and 6. I'm going to calculate from 0 to 6 probabilities, then choose 3, 4, 5, and 6 to add them. So let's go to Excel and do that. In this case, our n, excuse me, sorry, n equal p equal x. X will be x equals 2, 3, 4, 5, and 6. So, excuse me, that means you're going to calculate the probability of 3, probability of 4, probability of 5, probability of 6, and add them. So I'm going to write my x here. I'm going to calculate everything from 0, 0, 1, 2, 3, 4, excuse me, 4, 5, 6. Okay, and the px. Okay, so that we can have a probability of p of at least 3. So I'm gonna make it like that. Okay, bold it. Okay, let's calculate the probabilities. Remember the formula: binom equals binom dot dist equal binom dot dist. Pops out. Our numbers is specified from 0, comma. How many trials? Well, I didn't put our n. Sorry, my brothers. Let me start all over. The n, we wrote the n as 6. P as 45%, which is 0.45. Okay. Equal binom dot this. Pops out, double click. Numbers from right here as x, comma. Number of trials. Okay, 6 trials. The probability is 45%, that means 0.45. And we're using probability density function, so you're gonna put false here. Put enter key. Give me the first one, so I'm gonna copy it down so you can get the rest of them. I'm gonna make it 3 decimal places so that the probability of at least 3 will be at 3 or more. That means from here all the way down. So it equals this plus this plus this plus that. I'll give you the required probability you're looking for. 0.558 is the required probability. So any question on this? Any query? Okay. So since there's no question, we're gonna be looking at the mean, variance, and standard deviation of a binomial distribution. That one we do next week when we meet next week in the campus. Now, let me get your names and then let you go. I get some of them. I get most of your names anyway. Ali, you're right. Ali, you're right. Are you there? Ali, you're right.
Here. Hello.
You there?
Yes, I'm here.
Okay, let me write this time. Ali. Ali. Okay. I check that. I have got the rest of you actually. Let me see. Cedric. Cedric. Yep, I got it. What am I missing? Mata. So I got Mata already. So far. Mhm. All right. Yes, more. Got that. Okay. All right, guys. I see you on Monday. Okay.
Okay, thank you.
Have a good one.
Have a great
Thank
night.
you. All right.